In this video, we will look into the elements in period 3. They are sodium, magnesium, and aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Don't worry, you don't have to memorize all of them. You will see that it's quite a bit colorful in here is because there are some special things writing them in this way. Firstly, all these yellow ones are actually telling you that sodium, magnesium, and aluminum, they are actually metals, while silicon is actually what we call semi-metal. As for the green color ones, they are actually the non-metals. So that's the first part, or you can say what we call the first things that you need to know about period 3 elements, or you can understand it as in periodic table they are metals, semi-metals, or we call them the metalloids, and also non-metals in them. Their oxide actually will also carry some very interesting properties. As you can see, the ones that is in red color and highlighted in yellow actually tells us these two elements, they are having basic, which means that when you put them in the water, they are going to produce alkaline solution. Or sometimes you can say that there's no way that they can react with any other bases. But for the red color one, it's a very special one because it has a very special property called amphoteric, which means that it can react with both acid and base. Not like the base we say that it can only react with acid. Well, the acid can only react with base. Okay, something is pretty straightforward. Okay, now as for silicon, phosphorus, sulfur, and let's say even the chlorine, their oxides are generally acidic, so there's not really much of a complication in there. But however, here's something that you might want to remember, which is the formula of their oxide. Now, of course, here are a few chemical properties that you might find interesting. So as for the basic oxide, we can see that when it start to react with acid, because no matter what, when you have acid and react with base, it is still going to give you salt. Well, some of them they will even give you water. That depends on whether you can find hydrogen inside your chemical equation. If yes, then you are quite likely that you're going to form water. So as you can see, sodium oxide reacts with sulfuric acid, it's going to give you salt and water, while magnesium is can react with sulfuric acid to give you salt and water. But of course, sodium sulfate and magnesium sulfate. Look at what kind of acid you're dealing with, and you will see where you can what kind of equation you're gonna get in the end. As for the acidic oxide, it might be a little bit tricky, so the concept is still the same. Acid react with base, still give you salt and water. So when you get this, okay, so because most of the time we are actually using sodium hydroxide as the alkali. By the way, most of the time you can let two solid things to react together. We'll always try to get one of them is gonna be a solid or gas, and there must be one solution in them. So which is why I'm writing the equation in this way, hopes to get everyone a good idea how this thing actually works. The one that might be a bit tricky is amphoteric oxide, which is in this case aluminium oxide. Aluminium oxide itself is something that can react with both acid and base. As you can see, firstly, aluminium oxide can react with the acid, hydrochloric acid, to give you a salt and water. In this case, my salt is going to be aluminium chloride. Whereas in the other one, when aluminium oxide react with sodium hydroxide, no matter what, do keep in mind you are still going to produce a salt and water. That is most of the time the rule that cannot be broken. So the salt that you're going to produce in here is what we so called the sodium aluminate. NaAlO2, and then of course with water. The water is definitely derived from the hydroxide ion inside sodium hydroxide, and the rest of them, yeah, that will make up your salt. There are no other things that is gonna be produced in here. And here's the chance that I'm going to introduce this, the AlO2 ions. Although it's not really something that can be seen commonly, but do remind yourself that this is what we so call the aluminate ion. Now, across the period, okay, this is the other term that we use to describe a lot of properties. In the few videos in the front, okay, before I've been using the word down the group quite frequently. You may say that this is exactly the opposite of down the group. Now, down the group is reading everything from the top to the bottom, while across the period is actually saying we are going to analyze things or take these things from the left to the left to the right. So, from the left to the right across the period, okay, there are a few things worth to be mentioned. Firstly, the atomic radius is actually decreasing across the period. And why is that happening? It's actually because the strength of the nuclear attraction force is increasing. Well, this is because of the number of protons is increasing, which makes your electrons is being pulled closer towards your nucleus, and then makes your atomic radius decrease. Now, of course, there's another thing that is worth mentioning, and then quite closely related to this, which is the metallic property and the non-metallic property. As for the metallic property is trying to tell you that it's actually quite close to the meaning of how we define that. It's the tendency of losing electron. So it means that if you can lose electron easily, then it means that the metallic property is high. If you are able to gain electron easily, it means that the non-metallic property is going to be high. Across the period, here's the thing. The metallic property is going to start to decrease, as you can see right here in this okay, you can see that our elements are actually changing slowly from metals and then becomes non-metal. It means that your metallic property is decreasing because atomic radius is decreasing. So it means that nuclear charge increase, and then helps you to pull electrons closer, have a stronger force of attraction on those electrons, which is why we can say that the non-metallic property is going to be decreased, since it's harder to lose electron. But however, it is going to be easier to attract electron, which makes the non-metallic property increase in here. There's a term that is used frequently as well, which is known as electropositivity and electronegativity, which means the tendency of losing electron and gaining electron respectively.